Welcome in the last section, that is the sixth one in our course. In this section, we'll be doing monitoring and deploying Spring Boot production application. So first step that we will do is measuring REST endpoints and data access layer with Micrometer library. Once we will know constructs from that library, we'll be creating REST endpoint for exposing custom metrics. When we will expose our metrics, we will expose metrics via Spring Prometheus library. Next step will be to make our application reliable with custom health checks. Once we will add health check, we will create a Docker container with payment application. That Docker container will be a good thing to deploy our ready container with application to Heroku Cloud. So we'll be able to expose application via Heroku Cloud. In this video, in which we'll be measuring REST endpoints and data access layer with Micrometer library. So first step will be to add meta registry. We'll be experimenting with available metrics and we'll be testing various types of metrics. So here's our metric setup. We are using the configuration bin to be able to create multiple bins from that component. So first thing that we need to create is Micrometer clock. So we are using system clock. That clock will be used to measure times of some executions when we are using timed metric. Then we are creating a collector registry, and this will be a collector registry that is initialized with defaults. Once we have both components, we are able to create a Prometheus meta registry. This is a component that is creating the meta registry. It implements that interface, so we are able to access a lot of useful metrics. But let's go through the metrics that are available. First and the simplest one is counter metrics. So this is a metric that is available and is useful to counting occurrence of the specific action. So we are creating counter using .counter method and we are giving a name. So it indicates instance count of the object. We can get any name that we want. So it will be a counter and then we are using action invocation measurement. So we are iterating 100 times and every time we are incrementing that counter. We can also of course decrement it, but we will be incrementing it. And at the end, that counter should signal that we have a 100 elements. So let's start the test and validate it. We can see it passed. Next metrics that is very useful and can also be used with application is response time metrics test. So this class, it also uses meta registry. We are using simple meta registry for a unit testing purpose, but it implements exactly the same interface as the Prometheus that we will use further in this course. So it is meta registry. So we can operate on that interface. Implementation is not important now. So we can create a timer that is a specific kind of metric that is used to measure the time of execution of the specific call. So we are creating timer, calling it timer of the method, and it will return the timer. Timer has a method that is called record that can take couple arguments. It can take, for example, runnable. Also, it can take a callable. So it can wrap the callable and return the return value from the callable back to the caller. Here we are using the runnable implementation because we have a method that does not return anything. So in this method, we are just sleeping for 1000 milliseconds. And after that, you are taking a total time of the execution in the milliseconds measurement. And the result is equal to V, that it should be greater than or equal to 1000 milliseconds because our actions take as long. So let's start the test. We can see that it passed as well. Fourth option of the metrics that is really useful is the gauge. Gauge is a metric that is available in the meta library and it is used to measure the number of elements in a collection. So here we are creating new cache using cache builder and we are specifying the maximum size of the cache should be equal to 10. And our loader is just taking the key and transforming it to the uppercase. So this is a simple code and it should use counter here together with gauge. So this test should use counter with gauge. So let's take it that this is only a gauge. So we can see that we can register the gauge on the specific collection using meta registry gauge method. Here we are passing the name of the specific gauge and this is called cache.size. And we are passing also the cache. So this is our collection. And third argument that is very important is a provider of the size of the underlying collection. So this provider will be called in some intervals that are specific to the gauge metrics. So then we are getting three values and we want to find a method that is of a type gauge and has a name cache size. It will return the optional metrics because it can be present or not. We know that it should be present, so we are iterating over every measurement in it. we are adding it to the list of measurements, and our list of measurements should get a value equal to 3.0 because our cache size is equal to 3 elements, and we should get that matrix because this is a current state of our measurements matrix. We can see that test passed, so it is okay. Final metric that is very important and very useful is histogram. So let's look at the histogram metrics test. We can see that, let's examine the first test. First test say that it should measure actions building histogram. So we are creating a new matrix registry, and we are using distribution summary using request sample symbol size. Then we are recording request of the size, let's say normal. We are specifying this at 20, and also then it is iterated 100 times, and one outlier that will be equal to 100. Then our distribution summary should have 101 elements, and the total amount of elements that were added to it should be equal to 2100. So let's start the test and see if distribution summary was able to capture it. We can see it successfully passed. We can use a request percentile, so distribution summary could be exposed with the quantile. So we are specifying that we are interested in the quantile 0.3, 0.5, and 0.99. So we will return the percentiles. So here we are recording exactly the same things, and we are specifying that we want to get the measurement, this distribution summary, and for each measurement we are adding it to the measurements list. Once we have that, we want to extract percentiles as the map. This is a method that is taking the measurement and takes the specific measure metric, and it gets the value. So then after that we have a result, and we can see that the result should contain 0.3. So percentile 0.3 is equal to 20, percentile 0.5 is equal to 20, and 0.99 is equal to 100. So this is important. Finally, we can create a linear histogram. So here we are specifying that we want to create a histogram that will have 5 buckets, and every bucket will be in the range from 0 to 10. The next one will be 10, 20, 20, 30, 30, 40, and 45, 50. So we will create a 5 buckets, and we are recording some values. We are getting the buckets, so we can see that from the bucket 0 to 10, we had 2 values, 10 to 20, 100 values, and infinity plus was 1 value because this is our outlier, and this is fall behind the bucket. We don't have a bucket for that.